Welcome everyone. This is 11.2 on complex numbers. So our previous lesson, we talked about imaginary numbers, right? And any number with an I in it is an imaginary number. So what we're going to do today is talk about complex numbers. And a complex number is just any number in the form A plus BI, where A equals the real number and B equals an imaginary number. Okay? That's all it is. Okay? It's just a real number plus or minus an imaginary number. All right? So that's what a complex number is. And I have a cool Venn diagram on complex numbers. Okay? So in one circle here, it's examples of real numbers, right? 17 is a real number. 3/4 is a real number. Square root of 2 is a real number. Pi is a real number. And any decimals are real numbers, right? And in this circle are imaginary numbers like 2i, -7i, I square root of 11, and 6.3i. So what a complex number is, it's just a real number like 3, like 4, or like 1, plus or minus an imaginary number like 4i, 2i, and I square root of 5. Okay? So it's just a sum or difference between a real and an imaginary number. All right? So what we're going to do today with these numbers are just do basic operations. We're going to multiply them, add them, and subtract them, and simplify them. So today's lesson, we're going to simplify. In tomorrow's lesson, we are going to do the rest. Okay? So we're going to run through some examples right now. And before we hit the I and the imaginary numbers, let's simplify this radical. Okay, square root of 63. Now remember, when we are simplifying radicals, we have to think about the perfect squares, right? Like 4, 9, 20, 16, 25, 36, 49, 64, and so on and so forth. So out of those numbers, what perfect square goes into 63? 9, right? So this would just be 9 times 7. That's 63. So the square root of 9 times the square root of 7. The square root of 9 is 3. So that's simplified down to 3 square root of 7. Easy. Yeah. Try something harder. 108. What perfect square goes into 108? 9. 9 times what? 12, okay. We can just pull out any perfect square. If you start off with 9, then it's 9 times 12. But if you notice that this 12 can also be broken down, right? Even further. What perfect square goes into 12? 4 times 3. So we have the square root of 9 times the square root of 4 times the square root of 3. Correct? 9 times 4 times 3. So the square root of 9 is 3. Square root of 4 is 2. Square root of 3. 3 times 2 is 6. So this would be 6 square root of 3. Okay? Another way we can break it down, so we could break it down just using any perfect squares, right? But we have to continue to do it as until we cannot anymore, right? But another way we can break down a square root of 108 is 36 times 3, right? 36 times 3 equals 108. So if you go square root of 36 times square root of 3, which would be 6 square root of 3. Doesn't matter how you do it, right? You will come out with the same simplification. Okay? Cool? All right. Now, what if there was a negative in there? Last lesson, we talked about square root of -1 equals I. So whenever I see a negative inside my square root, my first step is just to take the I, put an I on it, and take out that negative. Okay? So now 18 is the same thing that we did up there, right? With my first two examples. So square root of 18, 9 and 2. So this would be I square root of 9 times square root of 2, which you would have 3I square root of 2. Yeah. Cool? Yeah. All right. Next one is the square root of 90. Okay. I see a negative, or it's negative 90. So it's just I square root of 90. 90 breaks out to be what? 9 and 10. Now I know 10 is not is not a prime number, right? But there is no reason for you to go further and say it's 5 times 2. Because 5 and 2 are not perfect squares, right? So we're going to come back and put square root of 10 anyway. Does that make sense? So once you're done with perfect squares, you're done with the simplification part of it. So this would be I square root of 9 times square root of 10. 9 is 3, so this is 3I square root of 10. Okay. Questions on simplifying? No? Pretty simple? Yeah? Okay. Try this one. You guys try this one. So in this case here, I see a negative. So I'm going to take that negative out first. 192. So 192 is a pretty big number, right? And without a calculator, okay, I'm going to approach this without a calculator. Okay. I know that 4 goes into 192. Yeah. You can take out a 4, right? 4 divided by, or 192 divided by 4 would be 48. Yeah. And 48, we can break that down into another 4, right? 4 times 12. 12, you can break that down to another 4. 4 times 3. Okay? So we have here I square root of 4, this one, square root of 4 times square root of 4, this one, times square root of 4, this one, and then times square root of 3, which is this one here, right? Square root of 4 is 2. So I have 2 times 2 times 2 with the I, with the square root of 3. 2 times 2 times 2 is 8I square root of 3. Okay? So again, with the 192, you could have gone the route of 64 times 3. Yeah, the square root of 64 is 8. Or you could have gone 16 and 12, right? And then 12, break that down to 4 times 3. So there are multiple ways of simplifying. I just chose the longest way, yes, but the least amount of math brain power. Okay? Because I just started dividing it by 4. All right. So we're going to use that skill now to rationalize the denominator. Okay? So in order for me to rationalize this denominator, I'm going to first simplify the 28, the square root of 28. Square root of 28 breaks out to be what? 4 and 7, right? The perfect square of 4 times 7. Now, class, since we've done like 5 examples of this, can I just say, can we all follow that this will be 2 square root of 7? Yeah. Okay, if not, the sub-step would be 4 divided by the square root of 4 times square root of 7, which the square root of 4 is 2. That's how I went from the second step to the third step. But now if you look at this, the 4, the 2 and the 4 cancel out, make 1 and 2. So this would be 2 divided by square root of 7, right? Now what do I need to multiply here by to cancel out the square root in my denominator? Square root of 7. So I'm going to multiply this by square root of 7 over square root of 7, right? So if I multiply across, I'm going to have 2 square root of 7 divided by square root of 7 times 7, square root of 7 times 7, which is 49. And square root of 49 equals 7. So this would be 2 square root of 7 over 7. Okay. Questions? No? Simple? Yeah. The next one is 2 square root of 20. And I'm going to put it down here so I can work with it. Okay. 2 square root of 20. Okay. So I'm going to break down 20 first. Make that 4 times 5. Square root of 4 is 2. So I can say that this would be 2 divided by 2 square root of 5. Correct? Yeah. And these 2's would cancel out, make 1 and 1. So I would have 1 divided by square root of 5. Now I want to get rid of the square root in my denominator. So I have to multiply it by square root of 5 over square root of 5. And then this would be square root of 5 divided by square root of 5 times 5, which is 25, right? This, the product of square root of 5 times square root of 5 equals square root of 25, which equals 5. Okay? So that would be my answer there. All right? What are your questions? Yes. No, because we're not solving. Right now, we're not solving. Yeah. The question was, do we need a plus or minus? And the answer is no, because we're not solving for x. Only when we square root, right, and we're solving for x, we do need that plus or minus. Okay? Now, this example here looks difficult, but it's not. It's not. Okay? We're going to simplify the expression to a plus bi form. Take each square root and simplify it. So what is the square root of 49? 7. So this negative comes down. Negative. Square root of 49 is 7. Right? This negative comes down. What is the square root of negative 36? 6i. Can we all get there? Just in one step? Yeah. Plus, this plus comes down. What is the square root of 9? 3. This minus comes down. What is the square root of a negative 100? 10. Square root of 100 is 10. The negative 1 becomes an I. Questions? No? Okay. Now I have negative 7 and I have positive 3. Those numbers are both real numbers. So I can gather them. I can collect the like terms, right? Negative 7 plus 3 is negative 4. And then I have a negative 6i and a negative 10i. That'll make it negative 16i. And that's my solution. Or that's my simplification. Okay? Notice that it does become a complex number because the real number is negative 4. The imaginary number is negative 16i. Yeah, and we're just adding them together. Okay? Cool. Let's try this one. This one is a little bit more difficult. So we're going to drop down that negative again. And I see a 36. Square root of 36 is 6. Drop down this negative. Ooh, 50. So I'm just going to leave it as I square root of 50 and deal with that later. Drop down this negative. Square root of 25 is 5. And then drop down this minus or negative. What is the square root of 200? The square root of 200 is just I square root of 200, right? Now with 50, I can, wait, before I simplify what's in the radical, I can gather the real numbers up together. So negative 6 minus 5, that's negative 11, right? So now 50 breaks out to be what? What perfect square goes into 50? 25, right? 25 times 2. So does everyone understand if I put negative 5i square root of 2? as my simplification. Yeah. Okay. And then the 200. What number goes into 200? What perfect square? 100. So 100 times 2. So does everyone understand again? It's negative 10i square root of 2. Yeah. Because the square root of 100 is 10. Square root of 2 is just left as square root of 2. Just as the 25, the square root of 25 is 5. So this part goes here. And then the square root of 2 is just left inside. Right? So I have negative 11 minus 5i square root of 2 minus 10i square root of 2. And these two terms here, I'm going to try and get it without the arrows. Those two terms there are like terms because they have the i's and they have the same square root of 2. Okay? Like terms are like terms because they have the I and they have the square root, the same number square root. If it was different number square root, we cannot collect them. Okay? It's like having a real big strawberry and a little strawberry. Right? They're not the same. Yeah? So what's in the square root needs to be the same as well as the I. Okay? So here we would have negative 11 minus 15i square root of 2. If they were to be different, what's in the square root, yeah, then I would have 3 terms as my solution, not 2. All right? Yes. Yeah. Because you have negative 5 of these I square root of 2s, and then you're subtracting 10 of these I square root of 2. Okay? Any other questions? No? Let's do one more. Last one for today. Okay? So here, we're going to drop down this negative. What's the square root of 121? 11. Good job. Okay. Drop down the negative or the minus. Can we do this in all one step? Okay. What is the square root of negative 125? I just want the simplified version. Who can do that in their heads? Negative 5i minus 5i square root of 5. Understand? Because the 125, right? The I is just a negative. 125 breaks out to be 25 times 5. Right? Okay. Plus square root of 64 is 8. The minus comes down. How about negative 20? Besides Parker. 2i square root of 5. 2i square root of 5. Yeah? Everybody's good? Because 20 breaks out to be 4 times 5. Square root of 4 is 2. Square root of 5 just stays inside. And then the negative is the I. Okay? Now, since the real numbers, negative 11 plus 8 is negative 3. And then we have this guy here minus this guy here. So I have -5 minus 2, which is -7i square root of 5. So that would be your answer. Okay? Yes. You can go 10 times, so square root of 20. So I square root of 20, and then you can do 10 times 2, but the 10 can be broken down to 5 times 2. So remember, the first way I introduced this back in the first semester was find pairs and then take them out. Yeah. So that's the same thing. Yeah. Okay. So, but yeah. Yeah. Okay. So that's the lesson for today, class. Just to simplify radicals and to work with complex numbers. All right. And the next class, we are going to be multiplying them, adding them, and doing other operations with them. Okay. Thank you very much.